Hello everyone, welcome to our YouTube channel Electronics Maddy. In this video, I am going to explain working of a single phase half bridge inverter. In case you haven't subscribed to our channel, please do subscribe to it so that you'll be getting the videos that we post regularly. Alright, let's get started. This is the circuit diagram of a single phase half bridge inverter. At the first place, inverter is basically a device that is used to convert DC to AC. How is that achievable? I will be explaining in this circuit. So there are certain things that we need to take into consideration. So we are considering the polarity with respect to the load A with respect to B. So if A is positive, then the output voltage is positive. If A is negative, then the output voltage is negative. One simple important observation that needs to be made. So this is our convention. I hope this point is clear. We are using a 3-wire DC supply, so it basically contains three wires, that one is at this point, one is at this point, one is in the center. So these are not popularly used because the cost of 3-wire DC supply is very high. Now how do we analyze the circuit? It is very simple. Let us assume only one switch is turned on at a time. So when switch T1 is turned on, how does the circuit look like? It looks like this. So it is always important to draw equivalent circuits so that it will help us to understand the circuit in a better way. So T1 is turned on and T2 is turned off. So it acts as short circuit, and whatever voltage is applied will directly come across this point. How is that so? If you carefully observe, Vs by 2 will start acting as an energy source. Current starts flowing through this path, through this path, through this path. No current flows through this path because it is open circuit, and the current will flow through this path. The voltage will be plus and minus with respect to terminals A and B in this particular fashion. So the voltage that is appearing across the load will directly be Vs by 2 because Vs by 2 is the supply and it is a short circuit. So whatever is applied will directly be appearing at this terminal. That is, plus is directly connected to A, minus is directly connected to B, and that is why the voltage between these 2 points will be the same. That is, the supply and the load will be the same. So inference is output voltage is Vs by 2. One important observation that needs to be made. So why are we using diodes then D1 and D2? So in case we are using an inductive load, this explanation is specifically for resistive load, but if you are using an inductive load, the inductor will start charging with a polarity plus and minus, and when T1 and T2 both are turned off, it will be discharged through D1 or D2 depending upon the polarity of the output voltage. So that is why freewheeling diodes are used. So this is very important observation that needs to be made, so please make a note of it. Now what happens when switch T2 is turned on? The equivalent circuit looks like this. T2 is turned on and T1 is turned off. Consequently, current starts flowing through this path, current starts flowing through this path, and the voltage at the output terminals will be equal to plus and minus because plus is directly appearing across B, minus is appearing to A. Correspondingly, the voltage, the current starts flowing through this path and it returns through this path. So the output voltage here is negative because I told you earlier, if A is negative, then the output voltage is negative. That is according to our convention. So inference is output voltage is minus Vs by 2. So now how do we justify that we are getting an AC? How do we say that DC is converted to AC by using this circuit? It is very simple. Let us look at the waveform as how it looks like, and that will give you a clear understanding. Now I'll be turning on T1 and I'll be turning off with equal duty ratio. Again, I'll turn on T1. Consequently, this is the gating pulse that is given to T2. When T1 is turned on, T2 will be turned off, and when T2 is turned on, T1 will be turned off. So again, the cycle repeats. So how is the output voltage and current waveform look like? So this is the output voltage and current waveform. So in case of resistive load, both of them will be the same. It looks like this. Initially, when T1 is turned on, the output voltage will be plus Vs by 2. That is according to our inference that is observed. And once T1 is turned off and T2 is turned on, the output voltage will be equal to minus Vs by 2. So again, it from Vs by 2 it goes to minus Vs by 2. It changes instantly because it is the voltage that is obtained across the load terminals. Consequently, what happens in the next cycle, when T1 is turned on, current starts flowing through this path, and consequently the voltage also will reverse its polarity to Vs by 2. So again, in the next cycle, when T2 is turned on, the voltage will be equal to minus Vs by 2. So that is why, if you carefully observe, this is an AC waveform. A lot of students will be confused that how does this be an AC waveform? It is a square wave. So guys, don't be confused with this, because if you see, it has both positive and negative values, and it is periodic in nature with respect to the positive and negative halves. So it is not a sine wave, but it is a square wave. So it is an AC waveform. So DC is converted to AC, however the output is square wave. So we are converting AC to DC to AC, and these type of inverters are called as square wave inverters. So make an important observation here. So in order to convert it to sinusoidal, what do? We usually use an inductive load so that the current becomes continuous. So that will ensure that the nature of the load voltage will be sinusoidal in nature. However, these type of inverters are called as square wave inverters. Since 3-wire DC supply is required, that is one of the major drawbacks, so we'll be going for full bridge inverters. That will be explained in my next video. If you like this video, please do like it, share it, and subscribe to our channel for regular updates. Thanks for watching this video. Meet you guys in another video. Thank you.